Hello students, welcome to my YouTube channel. This is the JRF Soil Science class under the topic soil structure. It is a fourth part of the video. This will be the last section of soil structure part, and I will be going to take the uh, topics like evaluation of soil structure indices used in the soil structure evaluation, management of soil structure. So in the last class, we have studied about aggregate stability and factors influencing the formation stability. I think all have seen the video, and if you have any doubt, you can ask in the comment section. Feel free to ask any doubt, any type of doubt. If I know the answer, I will tell. If I don't know, I will refer and tell you guys. So let's go to the class. So first we can see the evaluation of soil structure, how we will measure the soil structure, the type of aggregates or amount of aggregates present in the soil. So we have two methods, direct method and indirect method. So the direct method is based on the shape, size and arrangement of soil aggregates, while indirect method are based on the determination of extent and stability of aggregates and properties related to the soil structure. You can say the methods, then you can you will understand the method. Okay, then first indirect method. The first method is microscopic method. So in microscopic method, what we will do is that a thin section of soils are examined in the laboratory in a petrographic microscope under polarized light, which clearly show the nature, shape and size of secondary particles and void. So microscopic method, directly we are looking the structure. So for that we will use a microscope under polarized light, so we can see the shape, size of secondary particles and void pores also we can see. So in laboratory we will use microscopic method to determine the soil structure. Here by using a microscope we are not measuring, we are evaluating the soil structure. Then next is a macroscopic method. So this is a direct method. So what we will do in macroscopic method, a chunk of dry soil is excavated from the field and is allowed to fall gently on a wooden plank or smooth floor from 3 feet height. The chunk breaks into small pieces of bed of different size and shape, form the cleavages. The geometric shape of the aggregates determine the type of structure. So we have studied about the soil structure, types of soil structure like plate like, prism like, brick, block like, uh, granular, etc. So when we from 3 feet height, when we for when we throw a chunk of dry soil to a wooden plank or smooth floor, it will break into different aggregates. So according to the shape of aggregates, we will say which type of soil structure is there. If it is a plate like structure, we can say it is a platey, so it has platey soil structure. If it is a round like granular, we can say it is granular. If it is of block like shape, we can say it is blocky. So these are very easy. Directly we are evaluating the soil structure. So microscopic, we are looking through microscope. Macroscopic, we are directly seeing the soil structure. Then next we can see what are the indirect method. So indirect method, first method is to measure the stability of aggregate. So it is evaluated by the degree to which soil aggregate resists the dispersion. Several indices are developed. For example, stability index. It is a difference between percentage silt plus clay as determined by the mechanical analysis, and that is obtained by suspension of soil sample in water. So by mechanical analysis, we will see the percentage of silt and clay present in the soil, and by uh, dissolving in what not dissolving, by putting the soil sample in water and allowing it to form a suspension, we can see how much silt and clay is present. Like all the sand will settle. Then what is present on the soil suspension? It is silt and clay. Then we will dry that. Then we will get the silt and clay weight. From that weight we will calculate the percentage silt and clay. So the difference between that is the stability index. So uh, for what measuring the stability of aggregate, stability index is there. It is a difference between the percentage silt plus clay, which is determined by the mechanical analysis, and the percentage silt and clay that is obtained by the suspension of soil sample in water. So when the stability index is greater the difference between means greater stability index, better is the soil structure. So for better soil structure, soil should have a greater stability indexes. So stability of aggregates, this stability means resistant to dispersion. Then next index is structural coefficient. It is given by d minus s by whole divided by s, where d is a percentage of particles less than 0.025 0.25 millimeter in diameter as determined by the mechanical analysis. S is the percentage of aggregates smaller than 0.25 millimeter in diameter as determined by wet sieving method. So we will see what is wet sieving method later. So by mechanical analysis, how much percentage of particles is have less than 0.25 millimeter diameter, that is D, and it should be what we have to do. We have to subtract this percentage, and the percentage of aggregates by the method of wet sieving method, we will get the percentage of aggregates. So that should be minus and whole divided by s. So we will get a structural coefficient. Higher the value of structural coefficient, better is the soil structure. And dispersion coefficient, water drop method are also there for determining the stability of aggregate. So structural coefficient should be more for better soil structure. Then stability index also should be more for better soil structure. Then next is a measurement of soil property. So we are indirectly evaluating the soil structure. So what we will do, we will measure the soil properties like bulk density, infiltration rate, hydraulic conductivity, aeration, available water, soil water, degree of compaction of soil, which is used for the evaluation of soil structure. So good soil structure, bulk density should be lower, infiltration rate should be greater, hydraulic conductivity should be greater, aeration should be greater, available soil water should be optimum. Optimum means a plant should get plants and the microbes present in the soil should get enough water. Then degree of compaction should be lower. So we can say the soil structure is good. The next is the size distribution of stable aggregates. Stable aggregates, how they are distributed in the soil, that we are evaluating in this method. So for that we are using dry or wet sieving techniques for determine the different sized stable aggregates. So here what we will do, we will by this method we will get how much percentage, how much amount different sized stable aggregates are present in the soil. For example, how much percentage of sand, how much percentage of silt and clay, like that we will get in dry or wet sieving technique. So first one is a dry sieving technique. So this dry sieving technique, proportion of aggregates which are stable against the vibrating action of stimulating or scoring effect of wind is determined. So we know dry soil will be subjected to wind erosion, is it? So here in dry sieving method, we are seeing the um, the percentage of aggregates which are very resistant to the wind erosion. So dry sieving provides index of characterizing the susceptibility of soil to wind erosion. So here dry sieving, we will use the principle is the characterization of susceptibility of soil to wind erosion. It is described by Chappell. So here Chappell is important. The scientist who gave dry sieving technique. It is Chappell. While wet sieving technique, the size distribution of water stable aggregates is determined. Here we are using water. So how much the proportion or the amount of aggregates which are stable to the water. It is determined by the wet sieving technique. So this is a wet sieving. We are using Yoder apparatus. This wet sieving method is given by Yoder. So we will call this apparatus as Yoder apparatus. So it was improved by Soil Science of America's Committee on Physical Analysis. It is well adapted to separation of large aggregates less than 0.1 millimeter, less than 0.1 millimeter. The lower limit of size more satisfactory is 0.25 millimeter. And treat the aggregates with ethyl alcohol before wetting to eliminate the destructive effect of water on wetting. So we don't want to study how we are doing how we are doing this wet sieving method. Just remember the Yoder who gave this technique Yoder. So the lower limit of size more satisfactory is 0.25 millimeter. Up to this we can measure. Then well adapted to the separation of large aggregates, it is less than 0.1 millimeter. The next we can see the indices of soil structure. The amount of different sized soil aggregates is represented by a single value for comparing the structural status of different soils or the same soil under direct management practices. So there are some indices like mean weight diameter, log standard deviation, change in mean weight diameter, coefficient of aggregation, geometric mean diameter, percentage of aggregates greater than 0.25 millimeter diameter. So first, mean weight diameter. This is a commonly used index. So what you have to study is the range of the mean weight diameter for saying that it has good structure. So all for example, if we are testing the soil and we got a range of um, nitrogen. So for optimum nitrogen condition content, we will have a range of value. So if the soil test value comes under that range, we can say that soil contain or soil is rich in or soil has optimum nitrogen content. So like that, these indices also have a range or some value. Above that, the structure will be like this. Below that, structure will be like that. That means that value you should be thorough. So commonly used index is mean weight diameter. So it gives an estimated of weighted percentage of average size of all aggregates. We will get average size of aggregates when we measure mean weight diameter. So it is a proportion by weight of a given fraction of aggregates to the total sample weight is multiplied by the mean diameter of that fraction. The sum of these products for all size fractions given gives the mean weight diameter in millimeter. So what we will do is that we will take the mean diameter of, for example, take the example of sand. So sand will have a mean diameter, that is the this what x. hmm? So x bar, it is a mean diameter of the fraction. So this weight is how much weight of sand is present. So how much weight is present. This is the W1, sorry, WI. Here it is a equation. Here the total sample weight. This is the total sample weight, and this is the weight of each size fraction. So this total is this one. Okay. So this means this WI means it is a fraction of weight of sand to the total weight of the uh, soil sample. Okay, total sample weight. So total soil sample weight multiplied with the mean diameter of sand. So like that, clay will have one value. Silt will also have one value. So we have to add all the value, then we will get mean weight diameter. The soil having mean weight diameter of aggregates greater than 0.25 millimeter are considered as good for the crop production. So mean weight diameter, if it is greater than 0.25 millimeter, 0.25 millimeter, that is considered good for the crop production. So if we are selecting a soil and we are doing this mean weight diameter in the laboratory, then uh, if that value comes greater than 0.25 millimeter, we can take that um, soil or land for the crop production. Then next is the change in mean weight diameter. It takes into account the stability of aggregates both under dry and wet sieving condition. Lower the difference into mean weight diameter, better is the soil structure. So what we will do is that we will look the mean weight diameter in dry and wet sieving condition. We will take the difference. If the difference is very low, the soil structure will be good. Then we can see the importance of soil structure. We have to study the mean weight diameter and the change in mean weight diameter only. It is mentioned in the fundamentals of soil science book. So just see what are the indices, log, standard deviation, coefficient of aggregate. If there is extra, we can discuss it while we are discussing the um, questions. Okay, MCQ questions. I will arrange one section for that MCQ questions also. The next is importance of soil structure. This just I will read everything. Soil structure influences almost all the plant growth factors like water supply, aeration, availability of plant nutrients, heat, root penetration, microbial activity, etc. Then strong aggregation decreases the detachability. That means it reduces the runoff and soil erosion. Soil structure is also useful for the classification of soil. Then it is affected by tillage, cultivation, application of fertilizers, manures, lime, gypsum, and irrigation. So these points I have taken from the Fundamentals of Soil Science book. And impact of soil management on soil structure. So we have there are tractors and farm implements, raindrop impact, foot traffic, compaction, repeated tillage, especially under wet conditions. These all will affect the soil structure very negatively. Tractors and soil implements will increase the compaction. Raindrop impact also, raindrop will also have a negative impact in food traffic. When we walk or when during grazing, the animals will walk on the ground and it will lead to the compaction and repeated tillage, especially under wet conditions. It will break the soil structure. It will disperse the particles. So it is very difficult for when we are using this kind of in the agricultural management agriculture system. When we are using this one, when our agriculture intensive agriculture, we are using these tractors and heavy implements, so everything it is affecting the soil structure. So how we can manage the soil structure, we can see tillage operations be carried out within the range of optimum moisture content to ensure least destruction of soil aggregates. So what happens is that we have to use the heavy machineries. We don't use the heavy machineries in a wet soil because it will destruct the soil structure. It will lead to the compaction. Okay. Then zero. Next point is the zero or minimum tillage practice be adopted to maintain adequate aeration and reduce the loss of organic matter through erosion, oxidation, and erosion. So instead of heavy tillage implements, just avoid the tillage or just do minimum tillage practice. Then we can maintain adequate aeration and reduce the loss of organic matter through oxidation and erosion. Next, soil surface be kept covered with the crop residues to protect the aggregates from the beating action of rain drops. Check the weed emergence and add organic matter. So to reduce the impact of soil or raindrops, what we should do, we have to follow cover cropping. So when the soil have the cover crops, the raindrop effect will not be there. It will reduce erosion. Splash erosion. You should know the word splash erosion. It is the first stage of erosion. So for reducing or for avoiding the splash erosion, we should cover the crop on the ground. That means cover cropping should be there. The next is incorporation of plant residues and manures into the soil for stabilizing the aggregates. That means increase the organic matter in the soil. It can stabilize the aggregates. The next is introduction of legumes in the crop rotation coupled with the application of phosphatic fertilizers. So legumes will increase the soil fertility. For the proper growth of legumes, phosphatic fertilizers is required, because the need of phosphatic fertilizers is for the root growth of the plants. So legumes we have to plant, then legumes will form the root nodule. That root nodule helps in the what nitrogen fixation. So for increasing the nodules, we have to increase the root. We have to increase the root growth. For that, we are applying the phosphatic fertilizer. So introduction of legumes in the crop rotation coupled with the application of phosphatic fertilizers is necessary. So in crop rotation, include the legumes. The next is the green manuring and cover crops are good source of organic matter. Just use the green manure crops and cover crops uh, for addition of organic matter. The next point is integrated use of organics and fertilizers for the crop production and maintaining adequate level of calcium or calcium content by applying some ground limestone. So limestone means calcium carbonate. So when we add calcium carbonate, calcium will increase the flocculation and helps in the aggregation. So just uh, remember, we have to reduce the tillage, um, go to zero or minimum tillage, cover cropping, legume in the crop rotation, then increase in the organic matter content, then application of phosphatic fertilizers, and addition of limestone, etc. These are good management practices to improve the soil structure. So we have seen many problems with the soils. So we can see how we will manage soils having structural problem. First, soil is sandy soil. What is a structural problem in sandy soil? It have low water and nutrient retention. You know the reason. It has more macropore, less micropore. So if there is more micropore, means there can be nutrient and water retention. The macropores will allow the movement of water and air to the pore. Their aeration and drainage pore. Hence, the sandy soil can't retain the water and nutrients. So this is the problem of sandy soil. So how we will manage? We can't manage it completely. Just we can improve the for improving the water and nutrient retention in sandy soil. What we can do? So first we add organic matter directly or through green manuring. Directly means we add farmyard manure like organic material, so we can increase organic matter content. The next is green manuring, or we can use green manuring for improving the organic matter. Next, increase the proportion of small sized pore for then addition of pond sediments, clay soil, or even compaction. So when we increase the compaction or add sediment from pond, then clay soil, when we add these and all to the sandy soil, just we can increase the proportion of small sized pores. Then low water and nutrient retention can be solved up to an extent. Okay. The next is a clay soil. So what is the problem in clay soil? It has restricted drainage and aeration. It is opposite to the sandy soil. It can it retain the water. It can hold the water, but it can't. It will hold the water. It will not allow their movement, free movement. So drainage and aeration will be restricted. And poor aggregation it may also have poor aggregation. Then for solving this to an extent, then we can add organic matter, but its amount should be higher. We should add higher amount of organic matter. The amount of organic matter we are adding to the sandy soil, it should be this clay soil structural problem should be can be minimized only when we add high amount of organic matter to the clay soil. The next is the crop rotation. The next is the use of phosphatic fertilizers. Then for reducing the problem of drainage, ridge or raised bed cultivation can be practiced in the clay soil. The next is a soil having prolonged water logging. So the puddled condition uh, due to the breaking of soil aggregates. When we grow rice in the soil, we are using this puddled condition. So when a soil have prolonged water logging, we can provide proper drainage. So this water logging problem can be solved. We can regain the structure of that lost structure of that soil. Next is the sodic soil. So sodic soil means sodium which is rich, soil which is rich in sodium. So problem in the sodic soil is dispersion. So its management we can add gypsum. Gypsum contain calcium. So calcium will be exchanged with the sodium. So the negative effect of sodium can be reduced. So with the addition of gypsum, we have to incorporate green manuring. We have to include green manure, other manures, etc. In incorporation of crop residues also can be done in the sodic soil. Next is arid and semi-arid soils. So this is a desert soil. So what is the problem with the desert soil? We have low stability of aggregates, low organic matter. So management, we can add organic matter, we can do mulching, etc. Then next is a small portion. It is a dispersion of clay. We know that calcium presence in the soil, it will increase the aggregation or flocculation. The opposite of flocculation is a dispersion. The net negative charge of phyllosilicate particles tend to make them repel each other. So this means that clay particles are negatively charged. So when these are negatively charged, they will repel each other. Like charges repel each other, unlike charges will attract each other. When these repulsive forces are strong, particles cannot approach each other and they are said to be in dispersed condition. So when these repulsive forces are very strong, it will remain in the dispersed condition. Mutual repulsion is enhanced by the monovalent cation at low concentration because under these conditions they have little neutralization on repelling negative charges. So when the clay soil have sodium, monovalent cations like sodium at very low concentration also, they can't neutralize these negative charges. Cation means the ions having positive charge. When they are present in the low concentration, they will not neutralize this negative charge. So the repulsion can be enhanced by the monovalent cation presence. Consequently, the soil dominated by the sodium ions will have clay particles in a dispersed state more so than the soil where calcium or other polyvalent cations are dominant. So sodium will cause dispersion, calcium will cause flocculation. Dispersion of soil particles is undesirable since dispersed particles lead to the small pores. Water infiltration is thus greatly reduced, leading to the standing water at the soil surface. So dispersion will it is very it is very, no, very harmful for the plant growth. So for a good soil structure, dispersion should not be there. So these all are about the portion of soil structure. You have to study the important portions very thoroughly. Just understand the concept only. Then there is nothing to thorough, like there is nothing for just understand the concept, every concept. So if you have any doubt in this video, in this lecture, you can ask, and feel free to ask anything, any doubt. And let's see in another video.